the screen.
Yeah, we can.
Yeah, so dear colleagues, hello everyone. I'm glad to be able to present this this little tutorial today. And today we will talk about competitions in the area of evolutionary computation. So what they are actually, why do we need them, how to participate in such competitions, and what can you get from this? And well, let us start. This is a short outline of my talk. So we'll also cover leading conferences in evolutionary computation, such as CEC, Gecko, and some others. And I will also talk about some other competitions that you might be interested in. So, but first of all, let us, of course, talk about why do we need some competitions? Why do we need to compete? Well, I believe that, first of all, we humans, we like to compete with each other. Well, in fact, we like to win the competitions, but for this we need to compete with each other. So competitions in every area, they arise at some point, but in some of the scientific areas, this is not very common, as it seems to me, at least. For example, it's difficult to imagine a competition between chemists or, I don't know, neurophysiologists or some other area. But in evolutionary computation, it is common, and it is widely spread. Of course, in machine learning or some similar areas, also we have competition, and it is essential that the algorithms that are present in evolutionary computation, that in fact they work, they operate by generating individuals and making them compete for the resources. So I find it quite interesting that the people who make evolutionary and swarm intelligence algorithms, they also like competing like the algorithms that they develop. And of course, this is not only just for the competition, just to win something. Of course, this is important for the whole area, because first of all, this allows the researchers to compare their ideas, to have some baseline, some basic level of performance of some method, and this allows people to see how well are they performing, how are the ideas, are they good or not? Because for some areas, maybe like for more theoretical areas, this is not important. But for evolutionary computations, when everything you can do is actually an experiment with a lot of randomness, competition is essential to find out if your algorithm is working well. So this picture on the right that you can see is, I've asked this popular neural network to picture two chromosomes which fight with each other. Well, I'm not sure if this is chromosomes, but at least it looks interesting. So let's continue about competition. What do they allow us to do? Well, for young researchers, this is a good opportunity to dive into new areas easily, and it is important because there are rules and examples on how to participate in the competition. So it is easier to dive into a new area if there is some description on how to do it. Second is, of course, you get to know the researchers in this particular field and figure out what people are working on the same topic as you are interested. And third thing that I should mention is that if you make a really good algorithm, it is a huge impact on the whole area of evolutionary computation. Just for example, in 2014, the Japanese researchers, Tanabe and Fukunaga, they made algorithms that won the first place, and 8 years later, today they have more than 1,000 citations on that paper. So this is definitely a huge impact. If you really do something important for the area, well, the whole world will know you. And this is, well, in my opinion, this could be more difficult if you just write a usual paper that nobody will see. Of course, there are some shortcomings, there are some problems. The problem is that every competition is focused on some design of the problem itself, or set of problems, the design of algorithms that can be applied. There are some limitations, and of course we should remember the so-called no free lunch theorem. So even if your algorithm solves all the problems in this benchmark, in this competition, even if you take the first place, this doesn't mean that your algorithm is actually good. At least it is good for this set of problems. But maybe for other problems, it will be not as good. So we need to remember this. So let's continue, and we shall talk about the leading conferences that have these competitions. So first of all, well, the two main conferences on evolutionary computations is of course the Congress on Evolutionary Computation, which is called like this. And every 2 years, I should mention that it is a part of the World Congress on Computational Intelligence, and that Congress also have several competitions. Second, the Genetic and Evolutionary Computation Conferences, so-called GECCO, is also a big one, a big conference. They have these two. The CEC and GECCO, they usually host some competitions together, but of course each of them has their own set of competitions. And the third is ICSI, or XC as I usually say. They somehow tried to get in this rather recently. Only this year they announced their first competition, so we will also mention this conference. Yeah, and one more question. Where do these competitions come from? Who makes them? Well, obviously some scientific groups around the world and around the globe, they develop competitions. Why do they do it? Well, there could be many reasons. Of course, this could be connection to industry, like some industry requires to solve some problem. They connect to scientific group and they decide, okay, we maybe don't know how to solve it, but maybe if we make a competition, someone will come up with a really great idea. So this is one way. Another way is, well, like for black box optimization, we just want to make the best possible algorithms for black box optimization. So at least these two ways are in existence. So let's go further, and we will first consider the competitions of WCCI, World Congress. Yeah, I've put some QR codes on the top right, so you may check out the links to these web pages if you're interested. Yeah, so here on the slide you can see the list of competitions that happened this year in 2022, and you can see that's quite a lot. And yeah, of course, there are the WCCI is a combination of 3 conferences, the conference on neural networks, fuzzy systems, and evolutionary computation. And as you can see, most of the competitions are from evolutionary part. So evolutionary competition scientists really, evolution computation scientists really like competing with each other. So yeah, let's have a look at some of the things that are here. We will go from the first one, which is actually from neural networks, but it's still rather interesting. Yeah, also, by the way, if you know, there are some competitions on machine learning, like the popular Kaggle website that they make competitions every year, every month, maybe. So this would be also interesting to check out. But we are more in the evolutionary computation area here. So let's first see what are the conference on neural network proposed this year. So the first competition is called the MetaLearn 2022, and it's actually made of 2 tracks. The first is meta learning from curves. So it's like learning from how neural networks are learning. So obviously you can have some performance score, and while you train your neural networks, there are these training cycles, and you get all kinds of different curves. So they're obviously different. If you change some parameter, you get a different curve. Maybe you get a better result, maybe worse. So obviously these curves, they encode some information, and the competition is to extract this information and apply to better training of neural networks. So this is first track, and the second is cross-domain meta-learning. So the idea here is that the participant should train a model that is able to adapt to different tasks. So, for example, you need a neural network or something else that can classify birds. At the same time, it can classify cars or flowers or something else. So this is also one of the competitions that they consider this year. Yeah, so the next one is called Learning to Run a Power Network challenge. So this is actually a long story, as you can see. So this started in 2019. Then continued in 2020, and so on. So what is this about? So the power networks are actually power grids with wires of electricity running through a country or between countries. And the problem of controlling it, or as they call it, running such a network, is quite sophisticated. And in fact, the word "run" is here not by accident. In fact, as they state, if we try to make an evolutionary algorithm that will learn to run a bipedal walker, like a human being with 2 legs, and we make some neural networks to run this in physical environment. This is very similar to actually controlling the power network. So that's why they call it how to run a power network. And this is crucial. You can fall into a blackout if your power generation, power consumption is not balanced. And when you're running, you also need to keep the balance. Otherwise, you also fall and probably get a blackout. So let's go on to the fuzz IEEE competition. So this year they have only one, and they have quite a long name, but this is about competition for co-learning on real-world applications. So obviously we all know that the fuzzy logic systems are they are good for human perception. It is easy for people to understand how fuzzy logic works because it's a white box model. And as I understood, of course, I could not dive into details of every competition. Here it is to optimize the knowledge base or the rule base with, of course, evolutionary computation, because it's the main way to generate a fuzzy system. This is for regression, classification, control models, so they have quite a lot also for robotics and other applications. So, but let's go on and let us see what are the CAC or Gecko competitions. So if you see that it's CAC/Gecko, it means that it's in both big conferences. So the first one is the abstract swarm multi-agent logistic competition. This is about the goal, of course, is to solve some logistic problems. So they have generated 10 small scenarios of simplified logistics, and the problem to be solved by some swarm intelligent or multi-agent or maybe evolutionary algorithm is to use several cooperative swarms or subpopulations, and these solvers should cooperate to solve this kind of logistic problem. So this is more about cooperation that is reflected in the name of multi-agent logistic competition. So let's go on, and here we will see several competitions on dynamic optimization, which is quite interesting in my opinion, because somehow it's kind of a hot topic today in evolutionary computation. So these dynamic optimization problems or DOPs. And this one is about seeking multiple optima in dynamic environments. So this is not a classical dynamic optimization problem when you have a changing fitness function, changing goal function. Here they also add this multimodality. So the goal is not only to find the best fitness, the global optima between changes, but also to figure out the positions of multiple optima. So here you can see some of examples of test functions on the lower side, lower part of the slide. So, for example, they have 8 functions and 8 change modes. These change modes are steps. So when the function is shifted, noise, all functions are noisy, recurrence, when the function returns to the previous state after some time, and also the number of global optima changes during the optimization problem. So let us go to the next one. The next is called competition on dynamic multimodal optimization. So you see again dynamic and again multimodal. As I said, this is somehow a hot topic these days. they have a different benchmark, so-called dynamic distortion and rotation benchmark. And yeah, you can see some of the scenarios that they provide. For example, they have like basic scenario or hard global optimization, or the scenario with severe changes when the function changes hardly, with irregularity, fast changes. So somehow it is, of course, similar to the previous one. But again, it is interesting that many researchers around the world, so this is different, completely different groups of scientists, they all interested in dynamic multimodal optimization. And the third competition on dynamic optimization problems, this is called generated by generalized moving peaks benchmark. So this doesn't have anything about multimodality in the name, but obviously, as you can see by the contour and surface plots of the problems that are generated by this GMPB, generalized moving peak benchmark generator, these are obviously the hard ones, and this is only in the two-dimensional. So this year they made a set of 12 functions, which are actually 12 scenarios with different number of peaks, up to 100 peaks, different change frequency, different dimension of problems, different shift severity, and so on. And again, I should say that this is all for single objective, unconstrained dynamic optimization problems. Okay, so yeah, we will talk about this one a little bit more. So because actually my second talk today will be about this benchmark. So you can see the definition of the test problem. There are some special things that they have: angle severity, shift severity, width, height, and irregularity. So you can see some examples of changing the function. So from the basic one, then irregularities are applied, then rotation applied, and so on and so forth. Ill conditioning also. But anyway, we will talk about this later. Let's go on to the next competition. The next is called the competition on heat pipe constrained component layout. And let us a little bit stop here, and I will describe what it actually means. So if you ever played on your smartphone, you know that it starts to heat very much, and there is a certain problem of cooling your smartphone or your laptop, for example, or your tablet. And the way that it is done is by so-called heat pipes that distribute heat between different components of your electronic circuit. And there is a problem that actually these heat pipes, they cannot cross each other. So they should go separately. And in this competition, and the goal is to find the optimal layout, how to put the components, how to put the heat pipes, and in the case when different components have different power consumption, and the heat should be taken from them. So they propose 4 problems with up to 180 design variables. So this is definitely relatively large scale optimization. And the thing is that here there are non-overlapping constraints, system central constraints, and many other constraints that should be satisfied in order to find a good solution. Okay, let's go to the next one. This is probably something that almost anyone can relate to, at least in Krasnoyarsk. This is so-called urban traffic signal control problems. So this is competition, I think proposed by Chinese researchers, same as the previous one. So they have a lot of electronic production and a lot of traffic problems, I guess. So the objective here is to revise the delay time that that cars or drivers take in the crossroads. So how to optimize the traffic, how to minimize the traffic jams in a city. So they generated a set of problems in a relatively large field. They simulated flows of traffic, and the goal is how to control the traffic signal dynamically to minimize the traffic jams. So okay, let us go to the next one, and the next one is relatively simple to understand, I think. This is just a competition on a single objective, bound constraint, numerical optimization. So the simplest one that you could imagine. You have a function f of x, and you just need to find the minimum. So it's that simple. But of course, the problems are not that simple, and they are specially developed to make problems for all kinds of methods. And this year, this is not the first, of course. Every year, the CSC and in Gecko, there are such competitions, and we'll talk about some special properties this year. First of all, previously the convergence speed was not important, so there was a computational resource like 200,000 function relations, and if you get the best function value at the end, well, then you did a very good job. This year there were only 12 test functions for 10-dimensional, 20-dimensional case, but previous years there were more dimensions. So just for understanding, here are some pictures of how the test functions look like. Of course, this is two-dimensional case, so you can see something classical like bent cigar or a Strigen function or something like sombrero function, but also some combinations of both, like on the bottom right, when you have a plateau and you have some kind of, I think it's Schaeffer's function, I'm not sure. Okay, anyway, let's go to the next slide and have a look at the competitions that are within the Gecko conference. So some of them are obviously, as I said, the same as in the CSC, like the first one on abstract swarm, multi-agent logistics, like real parameter single objective bound constraint optimization that we have recently seen. And but others are different. So we will talk about them in more detail. So first of all, this is, again, dynamic optimization, but different kind, dynamic stacking optimization in uncertain environments. This is actually developed by our Austrian colleagues in the University of Upper Austria, and their heuristics the Hill laboratory. And they have two tracks in this competition. They simplified and they derived from real world. And the idea here is that you have a crane that should take blocks and put them to some handover stack. So there is arrival and there is handover. So when the blocks are given to the next stage of production. I think this was about some steel production. So there is every block has a time until due. So of course you can stack blocks into buffers, and well, they shouldn't be this overdue. The blocks should not lie for too long. So you need to learn the way to stack them one on another so that you will not run out of time. So, okay, let's go to the next one. The next one is called evolutionary submodular optimization. And for simplicity, let's say this is somehow related to combinatorial optimization problems. And the aim is, of course, same as for most previous competitions, is to provide a platform for researchers to try their ideas and their algorithms. Here, the so-called IOH profiler, which we will talk about a little bit more later, it is used. But in this particular competition, it's about so-called submodular functions, where the benefit of adding solution components it decreases when you add additional elements. So okay, we will go to the next one. The next one is also quite interesting because this is a little bit about machine learning and about symbolic regression. So this is obviously for data science. Again, like competition with dynamic stacking, this has two tracks, synthetic and real world, and this is also partially done by our Austrian colleagues. And the thing is, you have to develop some kind of symbolic regression mechanism. So, for example, genetic programming. Obviously, this is the first thing that you could think of if you're familiar with evolutionary computation. So they have some benchmarking data, so-called the PMLB. This is synthetic data, and the thing here is that they estimate the accuracy, the simplicity of the equations that are generated by genetic programming, and also if the genetic programming system actually gives exact solutions to the problem. Like if you, for example, want to restore the law of gravity, if you get the exact equation, then it's perfect. For real world, of course, there are no exact solutions, so they attract some experts to see if the formulas that your system gets is actually making any sense. So let's go on, and this one is rather different from the previous ones because it's called Minecraft Open-Endedness Challenge. For the younger people, I think they at least heard about Minecraft. I'm not so young, so I'm not very familiar with this one. But let's talk about the competition. So they developed the Evercraft API. So it's a Python interface for the game. And what is it intended to do? You can write evolutionary algorithm or some kind of algorithms that will able to generate or manipulate blocks inside the game. So in Minecraft, you can generate all kinds of blocks, even some simple logic, for example, and then your generated program will need to control these blocks somehow. So this is open-ended. So there are no clear goals. It's like do something interesting, and we will see. Maybe it will be a good idea. So these are some examples of what was done by the top two winners. So on the right side, this is some kind of auto-generating logical system, and on the left. This is there were some two-dimensional and this is three-dimensional case of self-constructing blocks which have some interesting shapes like cubic or looks like walls or towers. So this is all generated by evolutionary algorithms. Okay, so let's go on and talk about the next one. This is also rather different. As I said, we will return to the IOH profiler. And this competition is about better benchmarking of sampling-based, or actually evolutionary swarm intelligent optimization algorithms. So, and the goal here is not to make an algorithm, but to make the benchmarking better. So how to measure the efficiency, how to make the code open source or user friendly for people who want to develop evolutionary algorithms or who want to apply evolutionary algorithms in their work. So they develop these two things: the Nevergrad and the IOH profiler, and these are actually Python libraries with genetic algorithms, some particle swarm optimization, differential evolution, all kinds of algorithms that you could use. And the competition is to contribute to this project. So if you make a good contribution, well, probably you'll get a good place in the competition. So I find this idea quite interesting. So it's like it open to everyone to do something good for the area, but personally, I have not involved myself in this so far. Okay, anyway, let's go to the next one. This is connected to the recently very important topic of COVID-19 pandemic, and this is about the optimization of simulation model. So this is planning of hospitals, how many people go to hospital, how fast the disease spreads, how to balance the capacity of hospitals, and of course this is expensive, high-dimensional simulation-based optimization. So the goal function is difficult to calculate. There are many variables, so this is quite a difficult problem, and of course, although this is like single objective numerical optimization, this is not so easy. Okay, let's go to the next one, and this one I personally really liked this year. This is called the SPOC. Space optimization competition, and this is actually organized or co-organized by the European Space Agency, in fact by their department called Advanced Concept Team, ACT or ACT. So this year they developed three competitions, three tracks within one competition. So they considered recently discovered TRAPPIST solar system with I think 7 or 8 planets that exoplanets actually that were discovered, and they developed three competitions about these star systems that actually exists and discovered and researched. So the first one is so-called system exploration. So there are several planets, and the goal is to design a tour. So the space shuttle or some kind of shuttle, yeah, should go through all planets. It should visit all planets and return back. So the goal is to find the pattern of controlling the ship. Where should we fly? How much fuel do we need? And of course, the problem of fuel and time. These are the objectives that should be optimized. The second one is called asteroid belt mining. Of course, there are ideas that once, maybe hundreds of years after today, we will mine the asteroid belt. So they considered this problem of finding, delivering resources, and this is actually a high-dimensional problem. So the first one had 34 variables. This one had 1,044 variables. And the third one is the resource delivery. So this is again about mining or delivering resources between planets, and this has 30,000 variables, which is absolutely terrible. And more, to add more, these are multi-objective constraint problems. So obviously quite difficult to solve. But actually, I gave the first problem to one of my students during spring, I think in April and May. I said that if you at least get non-zero results in the first track system exploration, you will get free of exam. But he didn't get very good results, but he was still very good trying to solve this problem. Okay, let's keep going, and we finished with CEC and Gecko competitions, and we'll talk about the ICSI or XC competition. So this year they made their first competition, and it is obviously based on the CEC benchmark. So they actually took the code from the CEC, they changed it a little bit, and they said, okay, here is our new competition. So it's 10 test functions, 10-dimensional, 30-dimensional, 50-dimensional, and basically the same numerical optimization competition. So let's go to the next part. I told about different kinds of competitions that exist, but how can we participate? What should I do? If you ask yourself, what should I do to take part in all this interesting stuff? Well, first of all competitions have websites. So as you saw, I've put the QR codes on every slide or almost every slide, so you could go to the competition website, or of course you could go to the conference or congress website and then find the competitions area. And all competitions have instructions on what to do, how to send, what are the rules, and so on. Next, some competitions require that you submit a paper to the conference, and then they will consider your results. Well, this is not obligatory for some competitions. Actually, for most of them, you just send an email with results to the organizers, and they will include your results in the competition. Usually, you can find a PDF file with a description of problems, so-called technical report, and this is like the basic file that you should be looking for every competition. And the results of the competition are presented at the conference usually. So until the special session, nobody knows who is the winner or who is the second place. So this is always an exciting moment for everyone. Another reason to participate in a conference. Let's take an example of CEC 2022. This is something that I personally went through this year, and not only this year. So we will consider the procedure of taking part in this competition. So they are held every year. So if nothing bad will happen next year, it will be again held within the CEC 2023. And the announcement for this and many other competitions is usually December or January, and the paper should be submitted in January or February. So it's not a lot of time to develop an algorithm, to test it, and to write a paper. So as I said, in previous years, there were many competitions, like 2017, 2018 had the same set of problems. And yeah, as I said, they change set of problems every year. In 2019, it was so-called 100-digit challenge that you should find the global optima with 10-digit accuracy. And there were 10 problems with 10-digit accuracy, so it's called 100-digit challenge. So 2020 was a low-dimensional benchmark, but there was a huge computational resource. 2021 had switched on and off bias, shift, and rotation to figure out which algorithms are sensitive to this kind of things. And this year, computation had a larger computational resource and more difficult test functions than previous years. So another thing that you should know if you're willing to participate in the CEC or in some other competitions on numerical optimization is the GitHub account of Professor Sugantan. Actually, if you're interested in evolutionary algorithms or numerical optimization, I would recommend you to visit this account just to see what's there, because there are a lot of things. First of all the results of all competition and all the source codes of all the best methods are there. If you want to see how different people implement their algorithms, to see their results, to compare on some competition your algorithm with the results of other scientific groups, this is where you should go. Also, as you can see, he has a so-called codes repository with a code for some most important papers of his or his students, PhD students, and so on. So I would really recommend you visit this one and see, maybe you find something interesting for your study. Yeah, a couple more things. The source code is usually publicly available, and you can go and download it. You can see some optimization, probably with random optimization, some simple Monte Carlo kind of like algorithm. And yeah, one more important thing is that you can program in either C++, Python, or MATLAB. So usually these three languages are available. Yeah, and most important, even if you have submitted the paper, you can still improve your results. This is also good to know. Yeah, so let's talk about the CEC 2022. There are some rules, as always. Otherwise, someone would find a shortcut. The first one is that the parameters of the method should be the same for all problems. So we are kind of modeling the situation that the method doesn't know anything about any problem. So participants are allowed to change the parameters depending on the problem dimension, and the random number generator should not be tuned. And also, algorithm should start with random initialization. So these are the main rules. If you look, this is more detail than maybe we should go into, but this is just an example. You have a folder with input data with rotation, shift, and bias matrices. You have, for example, this year the CEC 2022 test functions.cpp with test functions, obviously. You have implemented L-shaped algorithm as a baseline, and a short README on what to do, how to present results, and that's all you need to put in your code, test it, and write a paper. So here I put several slides from this year's competition, from the algorithms that I developed together with my colleagues. It's called NL-Shed LBC. So it has some features. So these are the slides from the conference, like it has nonlinear population size reduction. It has a biased learner mean for calculating the updated parameters. Then it has a change for the bias in the parameter adaptation, hence it's called the NO-shade LBC algorithm. And here are some parameters of the computation. This is our slides presented at the conference at the section with the computation. And as you can see, these are things that you should report. Also, you should report, for example, convergence graphs comparing to other approaches that are at the same computation. So, for example, this year there were certain algorithms that compete for the best results, and the results are the following. The ranking is that unfortunately we didn't get the first place this year, only second, but the first place in 10-dimensional case. But the third place, interestingly, is actually a modification of our approach from last year. So, as I said, it makes an impact. Also, the difference between first and second place is not very big. But anyway, second place is also very good. This year, we participate also in the ICSI competition, and here we took the third place. In fact, I didn't put much effort into this one, just took the best algorithm that I had at that time, ran the benchmarks and the results, and third place. So I think this is not a bad result, considering the effort put into this one. I will also talk a little bit about the generalized moving peak benchmarks. So here are also some rules. So, for example, participants are not allowed to change random seed, not allowed to change the MATLAB files, and not allowed to tune the parameters, and so on and so on. Quite a lot of rules that you should follow. To participate in the competition. I didn't participate in this one this year. Didn't have enough time to do this, but this is still interesting. And as I said, we will return to this GMPV benchmark in my second talk today. So usually, about the results, what do you need to report? You need to report the best, worst, average, median, standard deviation, several tables, send it to email to the organizers, and that's all you need to do. Some general recommendations. If you want to develop a good algorithm to win the competition, use statistical tests like Mann-Whitney, Friedman ranking, anything, maybe students tests, to compare to the best available algorithms online. So the codes are really available, publicly available for everyone, so it is better to use them. Also, it's a good idea to build convergence graphs and to understand how your algorithm works. And the one more thing is that competitions actually have their own ranking methods. Every competition actually puts some weight. For example, more difficult problems like 100-dimensional problems worth more than 10-dimensional problems because they are more difficult, and the algorithms that solve more difficult problems are considered better ones. Also, about some other competitions, I wanted to show this one, which I recently discovered only a couple of days ago, and this is also quite an interesting one, and it's connected to a video game called Space Engineers that I'm familiar with, and this is a competition of generating spaceships. So in this game,
Владимир, вас не слышно.
Can you hear me now? Yes?
Now, yes.
Yeah. Okay, so again, this competition is about spaceship generation, and it will be until the end of December, and you can participate. This is also generating with evolutionary algorithms. Yeah, there is one more slide that is still empty. It's called our own competition. Somehow, until now, we don't have one. And I believe this is a good idea to come up with some kind of competition of our own, of our vision of what is important for the field of evolutionary computation, what should be done, what are the drawbacks of other competitions. So I hope one day we will have something to put on this slide, but unfortunately not today. So in conclusions, I would say several things. First of all, the competitions is a great tool for beginners to learn something new, to dive into the area, to figure out how to do this, to see the source code, which is very important, and to know the people who do something in this area. Of course, it's better to start with relatively simple competitions, and it's a very good way also to publish your ideas. So the chances that your paper about participating in a competition, even with maybe not the best algorithm, the chances that your paper will be accepted is very high. So actually, I had no experience of getting rejected on the paper about participating in the competition. So, of course, competitions have limitations, so-called no free lunch theorem. So if you win the competition, doesn't mean that your algorithm is the best forever. So no, this is obviously not true. And finally, remember, it's the participation that matters, not victory. So with this, I would like to conclude, and I am ready to answer any of your questions. Thank you.
We even have 2 minutes to ask questions and get answers. Please, Alex. Okay, I cannot see anyone who would like to ask a question. It means that Professor Stanovov was absolutely clear and told everything quite understandable. I just, instead of question, would like to repeat what I wrote in chat. That Vladimir is winner of the world competition in computation in evolutionary computation the last year, runner-up this year, second place, and 3 years ago he was third one. It's exactly according to his recommendation that participation does matter, not winners.
Yeah, I agree.
Thank you very much, Vladimir. It was interesting to listen to.